I'll be discussing about the introduction to artificial neural network. So if you already know what is a biological neuron, that is fine. But if you don't know, so this is the structure of biological neuron. These are the dendrites from which these neurons receive some signals, and there are billions of neurons connected with each other. Like from these dendrites, there will be connecting other neurons. Similarly, with each branch, there will be connected some neurons. So these are called the dendrites, which are nothing just receiving signals from the previous neurons. So this is the nucleus where some signal being processed and it is being sent by the axons terminals, and these terminals send the signal to other neurons. Like this, there will be another neurons who will be receiving signal by the dendrites from the these axons. In a similar manner, artificial neural network has created. So these are the variables input, and these are some neurons. Like here, these are the different neurons, and each neuron receives different signals, and it process and gives some output to next level of neurons, and these neurons again give some output to next neuron. So here we get some output as a voice, and with each input there will be some weight associated with that. So W11 representing the weight with feature X1 going to neuron 1, and in this layer 1 there is superscript representing 1. Similarly, we have another weight. This layer is called as input layer, and this layer is called as hidden layer 1. This is hidden layer 2, and this is the output layer. Now we see what exactly inside the neuron. So this is the uh, exact mathematics happening inside the neuron. Same as the biological neuron, we have this as a dendrite, which are receiving some signals from the previous neurons, as here these X are being sent to the neuron. So this is the neuron which is receiving the signal from the previous neuron, and it is summing up with multiplication of some weights W multiplied by X. So summing this and applying some activation function. Activation function can be of different types. So these some activation functions are applied here, and it gives some output, and these outputs are sent to the next level of neuron. So here we will get some output and will be sent to next level of neuron. That is how artificial neural network works. So here basically two phenomena involved. First one is feed forward. So what happens in a feed forward? As name suggests, it is feeding forward. So this is the forward direction. We can see each neurons receiving signal from the previous one and sending the information in the forward direction. So here we receive some X values and process it and give output to the next value, next neuron, and these neuron again process it and give some output to the next neuron, and this is the final neuron, so it gives us some final output. So here this output will not be same as the actual output, so there will be some loss. So y cap indicate the predicted output, and y represents the desired or actual output. So there will be some loss. So here it will try to minimize the loss. So loss function we can use here MSC, like mean square error function we can use for the loss minimization. And next is back propagation. So when we get some loss from here, so it means that this structure is not correct. So what is not correct here is the weights, because all the process happening with the multiplication of previous output with some weights. So that weight, if we get some optimum weight, so we can minimize this loss. So we have to minimize the loss with respect to weight. So what we do, we send this data in a backward direction that is called as back propagation. So what happens in the back propagation? So we get some error at the final. So we send the information back to this neuron and it will understand, okay, there is some error. What I have done, it was not correct. So it will optimize its weight with respect to the previous year, and same information it will send to other neurons, and it will also understand that, okay, so the prediction I have done was not right, there was some error, so this neuron has to optimize its weight, so this weight will be optimized and this information goes up to the first layer of neuron. So this is what the back propagation is. So updation of web weights happens like this. This is gradient descent update equation. So weights updating in layer ij is equals to sorry, in a layer is equals to the weight what was previously minus alpha into del j by del w on weight in that layer. So what this del j by del w is, it is just j representing the error that was mean square we have seen here. Yes, this loss or error is representing by z. So here it is loss. It is differentiating with respect to the weight. So that's how we get some optimum weight and multiplying with the alpha to uh, regulate the speed of convergence. So here this alpha decide to take how much magnitude from this equation of del j by del w. So this is the learning rate and it will be updated till this gradient will go to 0. If you know the gradient, so it is like slope of a function with respect to this variable. If you so suppose imagine here is a function having some slope. So where this gradient will tends to 0, that will probably the minimum point, minimum of the function. That's how we get the optimum base, minimizing the cost RL. So this is a, feedback loop system, how the model works. So suppose model is producing some error from the training, and if error is minimum, so it's okay. If no, it will go and update the weight. So here, as you can see in this graph, if we get some error, if this error is minimum, so it's okay. This model will be finalized. If the error is not minimum, so the weights will be updated, and this loop happens for the updating till the minimum error we get. Okay, this is the convergence. Okay, now activation function. So we are talking about the activation function that was being applied inside a neuron. So activation function is nothing, just a transforming function which summed by summed each values multiplying with the sum weights. Okay, it should be differentiable because we have to calculate gradient. That's why it should be differentiable. So in 1980 to 1990, sigmoid and 10s function were being used as a activation function in neural network. So sigmoid function looks like this. So this is a sigmoid function, and this is the gradient of sigmoid function, and it is very easy to calculate. That's why this function was being used in 1980 to 1990. So here if you want to calculate the gradient of the function, you have to just calculate the value of the function, and then you have this fx and 1 minus fx, and you will get the gradient of the function. Okay, derivation is very easy. So this is a sigmoid function. This is sigmoid function, and this magenta line shows the range of its gradient. So it is uh, like this. Derivative is always less than unity, so we will understand what is the advantage of having less than unity. Now tan has function or like this, and it looks like this. And derivative is lies between 0 to 1. So problem with these functions are vanishing gradient. This was one of the important reasons people lost their interest in neural networks. So suppose this is the updation equation we have already seen. So calculating the gradient by the chain rule leads to very small value of gradient. As we have seen, the gradient of sigmoid functions lies between 0 to 1, so it is always less than infinity. So when you apply the chain rule, there will be number of derivative multiplied. So when you multiply some number which is less than 1, so essentially you get very least numbers. Like if you multiply zero point 0.3 with zero point 0.5 with zero point 0.2, you will get 0.03. So this value decreases very rapidly when the network is very large. That's why we don't use this sigmoid function, because you can see if this is 0, so there will be no further updation of it. As here we can see the chain rule. So if you want to calculate the derivative of L with respect to H1, you have to calculate like this. These functions are dependent to other functions. And there is some exploding gradient problem. More if the derivative output is more than unity, so multiplying more number of gradients which are more than one, it will lead to very huge number of values, and because of that it may not be converged. That's why in late 2010 people came up with different activation function. It's called rectified linear unit ReLU, and the function is like this. If x is 0, it is 0, and if x is greater than or equals to 0, it is x. And the graph is like this, and derivation will be 0 and 1. Now derivative is either 0 or 1. So no problem of exploding gradient because it is always 1 or 0. So no matter how many times you multiply, you will be getting only 1. So no problem of vanishing gradient problem because it is not less than 1. So no matter you multiply these number how many times, you will be getting 1 only. So it is easy to calculate also. So these functions become very popular in neural networks. So problem of dead activation due to zero value of gradient. So it have a value 0 left side of the function. So it have a dead activation due to zero gradient. Now to solve this problem, people have come up with leaky ReLU. What leaky ReLU is? It is nothing, just instead of like having 0 less on the left side of the origin, it has a small uh, gradient line passing like this. So we have uh, this liquid ReLU as x and ax. If x is greater than 0, it is x, otherwise it is ax. So this is the gradient we can see again. It don't have the problem of vanishing gradient.